Dear students, welcome back to my third part of lecture on elements of mechanical engineering. In the previous class, we discussed about the major parts of lathe and their main functions in the lathe. Today in this lecture, we are going to discuss about the generally performed lathe operations on the lathe machine. So here we can observe there are 5 different lathe operations. So first operation is called as plane turning operation, and second operation is called facing, and third operation is knurling, fourth one is thread cutting, and fifth one is called taper turning. Again, in fifth operation, that is taper turning, can be done in two methods. First method is called swiveling the compound rest, and second method is called offsetting the tailstock. So in the next slides we'll discuss in detail all these operations, how they are performed on the lathe machine. So now we'll go to the next slides. The first operation, that is the plane turning. It's also simply called as turning operation. So in this plane turning operation, the workpiece is supported between the two centers which permit the rotation of the workpiece. The cutting tool is fed perpendicular to the axis of the workpiece to given depth of cut and is then moved parallel to the axis of the workpiece. This method of machining operation, in which the workpiece is reduced to a cylindrical section of required diameter, is called turning. In this method, the cylindrical workpiece will be supported between the two centers. What are the two centers? One is called live center, that is the headstock, and the dead center, that is the tailstock. The tailstock will be supported this side, and this is the chuck which is connected to the headstock spindle. So here the one end of the workpiece is held in the chuck. Chuck is a holding device, and another end is supported by the tailstock, and the tool is fed perpendicular to the axis of the workpiece. Okay, you can observe this is the axis of the workpiece. The tool will be fed perpendicular to the axis of the workpiece, and after that it will be moved along the axis of the workpiece, so that we can cut the material and the diameter of the cylindrical workpiece can be reduced to the required diameter. That is called the plane turning operation, or it's also called as simply turning operation. This method of machining operation, in which the workpiece is reduced to a cylindrical section of required diameter, is called turning. Okay, so this is called the turning operation, in which the diameter of the workpiece is reduced to the required diameter by removing excess material from the raw material. So here we can observe one animation how the plane turning operation is done. You can see this is the carriage assembly, we already know, and the cutting tool is first fed against the rotating workpiece perpendicular to its axis, then it is moved along the axis so that it will cut the material and the diameter is reduced to the required diameter. Okay, so we'll go to the next slide. So here we have the second operation, that is called facing. This operation on lathe is used to produce either flat surface or shows at the end of the workpiece. The workpiece is held rigidly on the chuck. The cutting tool is fed perpendicular to the axis of the lathe from the outer edge of the workpiece towards the center. So here we can see the one end of the workpiece is held in the chuck. Okay, so this is the chuck and this is your workpiece that is held, okay, at one end, and another end there is no support of the tailstock. Other end, that support is not required. Why? Because we are going to cut the material at the one end of the workpiece. Okay, this is the cutting tool and it will touch the workpiece here at the one end of the workpiece, and it will be moved towards the center. This is the center of the workpiece. From here, when you move the tool to the center, okay, towards the center, so what happens, the rotating workpiece will be cut, and we can, when you move the tool once again in this direction, it will cut the material from this end to whatever the required length. Okay, and it will reduce the length of the workpiece. Okay, previous turning operation is used to reduce the diameter of the workpiece, but facing is used to reduce the length of the workpiece. Okay, so this is called the facing operation. So next we'll go to the next operation. So that is called knurling. It is an operation used to emboss serrated surface on the workpiece using a knurling tool. It is used to produce straight, angled or diamond pattern on the workpiece mainly for gripping purpose. Okay, so this knurling operation is done on any product for gripping purpose. Okay, we can observe in our day-to-day life some products require gripping. We have to hold the products at one end sometimes. Okay, so in those cases we can use this knurling tool and we can produce some different patterns. Okay, we can produce different impressions on the cylindrical surface of the product or the surface of the workpiece. That is called the knurling operation. Okay, what are all the different surfaces produced? One is the diamond. Okay, diamond shaped impressions. Okay, we can produce on the external surface of the workpiece, cylindrical workpiece, and we can produce angled surface, okay, angled impressions or straight impressions also by using a knurling tool. So here we can see how it is done. This is your cylindrical workpiece held between the two centers, that is the headstock and the tailstock, and this is the knurling tool. Okay, knurling tool will be fed against the rotating workpiece that will be rotating at 60 to 80 rpm, and we have to fed the knurling tool. This is the knurling tool whatever you are seeing, and it will touch the workpiece and it will apply some pressure on the workpiece surface so that the knurling tool will be harder than the workpiece material, so that okay it will produce the impressions. Okay, impressions will be made on the external surface of the workpiece for gripping purpose. This is called the knurling operation. Next we'll go to the next operation. Okay, and before that we can observe here how the knurling is done on the cylindrical workpiece. Okay, so this is the knurling tool. It is pressing against the rotating cylindrical workpiece, and whatever the impressions the tool is having, the same impressions are produced on the external surface of the cylindrical workpiece. So next we'll go to the next operation, that is thread cutting. A thread is a helical ridge formed on the cylindrical rod. This operation generates V threads or square threads on the workpiece. Okay, so thread cutting is the helical ridge formed on the external surface of the cylindrical workpiece, that is called the threads, and the whatever the operation we have done, that is called the thread cutting operation. Generally we can produce two types of threads. One is called V thread, one is called square thread. The workpiece is held between the two centers and rotated by maintaining a appropriate gear ratio between the spindle and the lead screw thread of required pitch can be cut. Okay, in the previous class I told what is the main function of the lead screw or the okay, so the lead screw is used only during thread cutting process. Okay, so by using that lead screw we can produce the thread on the external surface of the cylindrical workpiece. The tool moves parallel to the lathe axis. Okay, that we can see here in this diagram. The cylindrical workpiece is held between the two centers, live center and the dead center, headstock and the tailstock. So here this is the tool, okay, threading tool. This is called the threading tool, which is fed against the slowly rotating workpiece. Okay, then the tool will cut the threads. Okay, so if you want to thread up to this length, we have to move the tool from this end to this end so that it will cut the threads to the required length also. So first we have to fed the tool perpendicular to the axis of the workpiece, then we have to move the tool parallel to the axis of the workpiece, then you will get the threads. This is called the thread cutting operation performed on the lathe. We'll go to the next operation, that is called taper turning. Okay, this is very important operation. So what is taper? It is an operation done. What is taper turning? It is an operation done on the lathe to produce conical surface on the workpiece. It can be done by two methods. Okay, sometimes we need to produce conical surface on the external on the cylindrical workpieces. Okay, so in those cases we can use taper turning operation and we can produce the conical surface. Okay, these conical surfaces are having many applications. Okay, so these can be used in many applications for many many types. So there are two methods already I told. First method is called swiveling the compound rest. That is the one method used to produce the taper surface. And second method is called offsetting the tailstock. Okay. So this we will discuss in detail now. So first method, that is the swiveling the compound rest. In this operation, the workpiece is mounted coaxial with the axis of the lathe centers. The cutting tool is mounted on the compound rest and swivel to the required taper angle and locked. The carriage is also locked in the position. The feed is given to the compound rest which produces a taper on the workpiece. This is limited for shorter taper lengths. Okay, so we cannot produce the taper length to a more length, bigger length. Okay, only the smaller length of we can produce the taper surface on the cylindrical workpiece. Okay, in the sketch, okay, we can understand clearly how it is done. So you can see here the diagram. In this is the cylindrical workpiece. That cylindrical workpiece we can hold between the two centers. One is the dead center and the live center, or the headstock and tailstock. Then we can see this is the tool post. This part is the tool post. In the tool post we can hold the cutting tool. Okay, why the tool post is used? To hold the cutting tool. The cutting tool is held in the tool post, and this is called the compound rest. The compound rest is the part of the carriage assembly. Okay, so in the this compound rest can be swiveled to a particular angle. Okay, whatever the angle you want, to that angle we can swivel it. When you swivel the compound rest, the whatever the tool post which is mounted on the compound rest, and the whatever the tool held in the tool post, that is also will be swiveled, or it will be tilted to an angle. So you can observe here how the tool is tilted, but the workpiece will not be tilted. Understood? Okay, so now when you move the carriage along the length of the workpiece, or the parallel to the axis of the workpiece, the tool will cut the material and will get the required conical surface, the required angle. So this is called the method of producing the taper on the cylindrical workpiece by using this method, that is the swiveling the compound rest. So we'll go to the next method of producing the taper on the cylindrical workpiece. So here we can observe the animation, how the this compound rest is swiveled so that the tool is also tilt at an angle, and how we can produce the taper on the cylindrical surface. So we'll go to the next method, that is offsetting the tailstock. This is also known as set over tailstock method. That is the another name for this method. In this method, the tailstock of the lathe is offset to the axis of the lathe bed. When the workpiece is mounted between the centers, will be inclined to the lathe bed. The cutting tool is moved parallel to the lathe bed to cut the taper. This method is suitable for long workpiece having less taper. So we'll see in the diagram how it is done. We can see there are two centers. One is live center, another is the dead center, compound rest. So this is the headstock and this is the tailstock center, and the workpiece is held in between these two centers. You can see this is the cylindrical workpiece. Okay, so here only the tailstock center we are going to offset from the headstock center. So you can see how it is offsetted. This offset is shown here. Okay, so here this is the offset. When you offset it, but here the compound rest is not swiveled, it is perpendicular to the axis of the workpiece only. Only by swiveling this, we can incline the workpiece to at an angle. When you move the tool along the axis of the workpiece, it will cut the material and we can get the tapered surface on the cylindrical workpiece. This is called the another method of taper turning, offsetting the tailstock. Okay, so in the next video we will discuss in detail about the another machining process, that is called the milling. Till thank you all of you.